Subtracting fractions follows the same principles as adding fractions. You have to have a common denominator. So I'm looking at 16 and 12. 16 is the larger, so I write that down. Times 1 is 16. And then I need to decide, does 12 divide evenly into 16? It does not. So move up 1. 16 times 2 is 32. Does 12 divide evenly into 32? No. Try again. 16 times 3 is 48. Does 12 divide into 48? Yes, it does. So 48 is our common denominator. Hopefully you can start to do this process mentally, or at least with the help of a calculator, and maybe not write down so much. To turn a 16 into a 48, we multiply by 3, and also the top. To turn a 12 into a 48, multiply by 4, and also the top. Then just like addition, only the numerators are involved. 33 minus 20 is 13, and keep the denominator on the bottom. Check to make sure it doesn't need to be reduced, or if it's a mixed number that you need to, or if it's, an improper fraction that you need to change to a mixed number, you need to do that as well. The main difference between the subtracting fractions and the adding is the difficulty that comes up when you have to borrow. So before we start that, let's look at a few ways to write 1 as a fraction. 1 can also be thought of as 1 over 1. You can put any whole number over 1. 2 over 2 is also equal to 1. 2 divided by 2 is 1. 3 over 3, 4 over 4. So really, any number over itself is equal to 1. So keep that in mind. We're going to need to be borrowing 1 in these problems. But because we're dealing with fractions and we need common denominators, we'll need to write the 1 with whatever denominator we're working with. 5 minus 2 and 5/8. We're dealing with mixed numbers. Let's stack them up like we did with addition. I could do 5 minus 2 is 3, but there's nothing to subtract the 5/8 from. I need to have something in this spot. So I'm going to borrow 1 from the 5, which is going to be a 4. And then I'm going to put 1 in the spot, in the empty spot. But because I'm dealing with eighths, I don't want to write a 1 there. I want to write 8 over 8. Now I can subtract my whole numbers. 4 minus 2 is 2. And 8 over 8 minus 5 over 8 would be 3 over 8. If the fraction that's by itself is on the top instead of on the bottom, like this problem, then there's no need for the borrowing. The 5/8 just drops down. Think of it as 5/8 minus 0. And 5 minus 2 is 3. Now let's look at this problem. For the fraction part, we have to get a common denominator. 5 and 9. Maybe without going through the whole big process of writing everything down, we can think that 5 and 9 both go into 45. So we've got 16 and 8, and the fractions have a common denominator of 45. Then to turn the 5 into 45, multiply by 9, and the top also. To turn the 9 into 45, multiply by 5, and the top also. But now we've got a problem. We can't subtract 18 minus 20. We're not yet dealing with negative numbers. So 18 is too small. We need to borrow 1 from the 16, add that 1 to the 18 over 45, so that we can have a large enough number to subtract. So if I borrow 1 from 16, that gives me 15. and I need to add 1. But I'm dealing with a denominator of 45. So remember we said anything divided by itself is 1. So 45 over 45. Now my problem becomes 15 and 63 over 45 minus 8 and 20 over 45. Now we can do the subtraction. 63 minus 20 is 43 over 45, and 16 minus 8 is 8. Just like there are special addition words, there are special subtraction words. Difference, decreased by, minus, less than, all tell us that we're going to use subtraction. The one that's tricky, and I want to look at just a little bit, is less than, because it's easy to write the problem backwards. Suppose we have what is 1/3 less than 5/3. What we're tempted to write is 1/3 minus 5/3. But this is backwards. If I say I have $2 less than you, then you would subtract the $2. If you have 7 and I have 2, and I say I have $2 less than you do, it would be 7 minus 2, not 2 minus 7. So this problem should really be written 5/3 minus 1/3 equals 2/3. So be careful when you see the phrase less than. You're going to have to switch the order of the numbers that they give you.